Rachel Ernst, and this is the chemistry of latte art, my bonus assignment for chemistry 2. So why does latte art even work? Well, it looks like art, but a lot of people wouldn't even guess that it's actually science. It requires milk, heat, air, and controlled pouring. So the milk foam that actually goes into the espresso is foam, which is gas, and liquid, which is milk. These together is a colloid because the air bubbles, which we call microfoam, are trapped inside of the liquid. The proteins stabilize the foam. The milk proteins, which are classified as casein and whey, are heated, and these proteins unfold, which in chemistry we call denaturing. It surrounds the air bubbles, and then it prevents the bubbles from popping. This allows for the microfoam, which is how it's actually possible for the milk to make a design on top. So, why the foam holds together? This is all due to intermolecular forces, which are the attractions between molecules. In chemistry 2, we learned about London dispersion forces, dipole-dipole forces, and hydrogen bonding. Well, in this form of forces, we use hydrogen bonding between the water molecules. And then we also have proteins bonded to other proteins. These forces stabilize the air bubbles and prevent foam from collapsing. And here's a cute little picture of one of my bears that I did. This is controlling surface tension. Surface tension normally collapses bubbles. The proteins reduce surface tension, and this allows foam to stretch and hold shape. This is a similar idea to how soap works. Heat is very important when it comes to latte art. It can't be too hot or too cold. It has to be right around 140 to 150 degrees Fahrenheit. If it's too hot, the proteins are going to break down and the foam is going to collapse. If it's too cold, it's going to be weak foam and it's just going to sink to the bottom. Pouring creates the design. So when I pour latte art, this is the hardest part, like actually keeping my hands steady and making a good design. The flow of milk affects patterns. The foam sits on top of the liquid espresso because of the density, and then the controlled motion is equal to shapes, which creates hearts, rosettas, and all the other shapes I've shown you. So a lot of people don't know that a bunch of milks behave differently. This is because of the protein content in it. The more fat the milk has, the more proteins it has, which means the more barrier around the air bubbles, which means that the air bubbles won't collapse. More protein equals better foam. The fat can help texture, but it also can reduce stability if it's too high. Non-dairy milks behave much differently. So when I want to do latte art, since I'm still a beginner, I want to do whole milk and 2% milk. Any other milk like almond milk, coconut milk, soy milk, and non-fat milk, they all do not work very well because they all just sink to the bottom. It takes a really intense precision on the aerating for it to actually come to the top. So let's observe. Here's a picture of my own tulip, and I'm about to show you a video of how we make tulips. Okay, so before this video starts, we have a base of a mixture of espresso and milk. So how to create that base is you move the milk at a high position in a circular motion until it's all one light brown color. And then once you're ready, which is like halfway through, once you're ready to pour the milk into a design, you move the pitcher closer to the cup and closer to the surface area of the espresso. As you see in this one, we are creating layers of milk, and then you can see that at the very end, he lifts the steaming pitcher up to make the milk fall through the design and create a line right down the middle. Up and fall through. And then we have another one, which is, here's one of my cats. I don't know if you can see it. This is the cat latte art design. And so basically, on this one we have a huge white blob to begin with for the milk. So you have to aerate it for about 2 seconds longer to get a little more microfoam inside of the milk. And then once you pour it up, you make a big blob. And then to create the designs, you have to dip the stylus into the espresso part to create the designs on the milky part of the latte. In conclusion, there's chemistry in every cup. Latte art depends on colloids, protein chemistry, intermolecular forces, which as we discussed before are London dispersion, dipole-dipole, and hydrogen bonding. It also depends on temperature. It can't be too hot, can't be too cold. And lastly, it's not just art, it's applied chemistry.